Hi, everyone. I'm going to take you through what is expected for Chapter 22 today. I'm going to take you through this practice problem that is essentially following the same process as the proportions. It's just now we have different parameters and need to set up with a t-test instead of a z-test. This week, I expect that you work on the practice problems for Chapter 22. I'll put that problem set into your folders. I'm also going to put in a key, so as you work on it, you can be checking your work as you go. In addition, you'll get some immediate feedback from a few practice problems in Math Excel. So I will send all of that to you in an email. So first of all, when we look at this problem, you can see that we are dealing with averages, and that means we have to switch over to means instead of proportions. So I've marked up the problem to find the mean, to find the sample size, the sample mean, and the sample standard deviation. So the first thing you need to do is write your null and alternative hypotheses, which is done down here. So the average American sees 3.9 movies at the theater per year. The average American sees more than 3.9 movies at the theater per year. The one thing I want you to be aware of is we are dealing with a problem that says that he sampled his friends and family. So we are dealing with a convenient sample, meaning the randomness for the conditions isn't going to be met. What you do say here is that you just proceed with caution, because usually on the AP test, there's a follow-up that asks what you want to comment on. So when I take a look at what's in red here, the sample size of 30 is less than 10% of all Americans. We can assume that based on the central limit theorem, the distributions of the samples will follow a normal model. So the normal model is right here. We have our sample mean and our sample standard deviation. So when I talk about naming the test, I'm going to mention that conditions are met to perform a one sample t-test at 29 degrees of freedom. So that number right there is the sample size minus 1. You also want to make note, as I did, that you will proceed with caution because the sample is not random. In green, you see that I've done the t-value. So t-values are just like z-values, they're just more variable, okay, because they're based on sample size. So just like any other z-test, in a t-test, you start with your data. So that's what I had right here. My data told me a sample mean of 4.5. Then you have your null mean, which was 3.9, okay? And you're dividing by the standard deviation, okay, which is adjusted for the square root of sample size. You divide by that. My calculator did all of that work for me in a t-test, which I'll show you in just a minute, but gave me this t-value of 2.74. So again, you're still following the premise that beyond 2 standard deviations is going to be unusual. So looking at the probability that my t at 29 degrees of freedom would be beyond 2.74 is going to be 0.005, a very low, this is your p-value right here, okay? So let me show you in the calculator what I did there. So in the calculator, we're going to go to stat, move over to test, and it's on the second one right here. Once you hit enter, you're going to have two choices. Are you going to give the calculator your data in a list, or as in this case, we're going to give it the statistics. So I'll enter there. My null goes in this spot, the null mean. My sample mean goes here. My standard deviation was 1.2, and my sample size was 30, okay? So we had an alternative hypothesis of greater than, and so let's have it calculate first. So what I did is I had it calculate and I wrote down my mechanics from this information right here. Then what I did was go back to stat test. Okay, this is number 2 again. Data's still there in my statistics. So I'm going to now draw this and see what it looks like. And we should see very little shading. And again, it marks the t-value on there for me. So once I have all of that information, that's how I did all of the stuff that I have in green here. So knowing that my p-value is so low, I don't need to define a significance or alpha level because I'm below 10, I'm below 5, and I'm below 1%. So with a p-value so low, we reject the null. There is evidence that Americans are seeing more movies at theaters. So moving on. The student insists to his media teacher that movie attendance is on the rise, and I'm asked, do you agree with the conclusion? So at this point, I'm going to say, no, I do not agree with the student, as this was a convenient sample, not a random sample. So usually when they follow up with a question like that, there was something wrong with the test because you've already agreed with his conclusion by the mathematics part, so they're asking you for a concept part. Next, I was asked to do a 95% confidence interval. So for this one, going back to the calculator, okay, I'm going to go to stat and move over to test, go down to number 8. Okay, that's your t interval. Okay, again, all my data is already there. So I just need to calculate my confidence interval and write that information down. Okay, in order to show my mechanics, I'm going to need a critical t-score. So first, let me show you where that comes in. So as with any confidence interval, you're going to start with a sample value. That was my sample mean. Plus or minus, instead of a critical z-score, we have a critical t-score at 29 degrees of freedom, okay, times your standard error. So the standard error is what we took from above. This is s sub x divided by the square root of 30, okay? And in order to get that inverse t-score, I'm going to go here and I'm going to say I'm going to say second vars, go down to number 4, inverse t. We wanted 95% confidence, so we're going to go 0.975. Remember, you need to leave half on each side. My degrees of freedom here is n minus 1, 29, and then I paste that in, and 2.05 is my critical t-score. So with that information, you can follow my work down here. I show what was entered in the calculator, and that 2.5 is going to be my critical t. So with that, I'm 95% confident that the true mean value of the number of movies seen in theaters by an American is between 4.05 and 4.95. Go back and take a look at all of the parts of this again. Okay, I'm going to zoom out a little bit just so you can see what is happening here. Okay. Essentially, we're working on the same process of phantom. Okay, so the null hypothesis and the alternative make up the pH. Okay, then we have assumptions and conditions. That's right here. We name the test. Okay, then we do the test mechanics and obtain a p-value, and then we make a conclusion. Okay, with the confidence interval, we don't need to go through the whole panic process because we've already done the assumptions and conditions up above. But just to point out, when you need assumptions and conditions, if you look on the inside cover of your stats textbook, the back inside cover, you'll notice the page to the left shows all the assumptions that you need for inference, so you can refer to that. But basically what we need to prove every time we're using a one sample mean is we need independence, which is proven with a random sample, okay, and less than 10% of a population. And we also need to check if we're using data, okay, that the data is symmetric, is relatively symmetric and unimodal. Okay, so we'll look at some problems like that on the problem set. So make sure that you check the step-by-steps in chapter 22 in order to work through your problem set, and I will put a key in your folders as well.